Hey, hello everyone. Welcome to this new video about Microscopy Image Browser. And in this video I'd like to talk about application of Segment Anything model and how to install and how to use it in Microscopy Image Browser. Segment Anything model was developed by Meta AI research team, and it's pretty cool stuff because it allows you to do segmentation of data sets basically with just a single mouse clicks. Here you can see some examples how it works. So for example, on the left side, it's the segmentation of cellular profiles from the serial block phase scanning electron microscopy dataset. In the middle, segmentation of mitochondria from the dataset acquired with electron tomography. And here with the segmentation of lipid droplets from a dataset acquired with the focused ion beam scanning electron microscopy. So in each of these cases, basically the whole organelle can be selected with the single mouse click, but if it doesn't really work, then you can use the control. For example, here you can see that control click removes material which should not belong to an object. This is really cool research, and then if you want to see details, you can follow these links, and again they will be in the description. If you open this link, you can get to the actual description. There is a very nice demo that you can try. You can upload your own data set and see how it works with your data. That's why it's really nice. And also they have the actual they have a description about the data set that they used, as well as the scripts that were in the GitHub, which you can actually download and use. The actual preprint is also available on arXiv, and then if you're interested, you can take a look on that. This video will have like a couple of parts. So the first part I will tell how to actually install the required dependencies, and then in the second part I will talk more about how we can actually use this tool. Well, let's get started. In the Microscopy Image Browser website, you can go to the downloads, and then there are the system requirements. And then within these optional requirements, there is the Segment Anything model. And the whole thing that I want to talk is just we'll follow these steps and see the installation of Segment Anything for MATLAB and Microscopy Image Browser. So here's our MATLAB. There's different steps here. It's important actually to take a look on the requirements, because it's actually have quite modern requirements. At least you needed MATLAB released 2022A or newer. Then there is a certain requirements on Python. Then there are certain kind of would be cross relationships between the Python versions and MATLAB versions. And also it's important that you need to have a GPU. Segment Anything is actually works on GPU. You can also do it on CPU as kind of test, but it's not really that much practical in the long run because it's relatively slow. What are the installation steps? So first we start with installation of Python. The best actually to install Miniconda, not the full Anaconda, but Miniconda, because I personally like when there is more control of the things that are that I'm installing. And then if you install the whole Anaconda, like it's actually everything. It takes a lot of space, it takes a while to install and things like that. Personally, I like to install Miniconda. What we do then, we go to this Miniconda page. And well, I mean, I tested this on Windows. Maybe apparently should also work in the other operating system. But let's say I'll go to Windows, and I think, yeah, so they're here at these different releases. And I was testing it on version 3.9. Perhaps this is really the recent one, so I just download this. So let's put here like Python. Download this. There are two ways how it could be installed, sort of. It depends on the particular configuration of the system. So let's just go to that directory. So this is our installer. Let's just do it. Because we have multiple users, so I install it for all users. If you don't have local admin, then you can just install only for yourself. Okay, and then typically I install it to my D drive, Python, and then create here Miniconda 3.9. Next. Basically, we're doing these steps. So with admin rights, so that's the place where I install it typically. All the users, then we check all these checkboxes, and then I make this environments directory available for read-write for the users. In this sense, it's sort of I can install it once and all users can use it instead of every user has its own directory. I go to this Python Miniconda installation environments. I go to the properties, security, users, edit, and then in the users I just allow, well, basically the full control. Okay, that's the first part. We installed Miniconda, and then here on the following you can also see how you can actually install it without admin rights. So it will go to the users directory, and there you basically put the Miniconda itself. The next step that we need to do, we need to actually download the segment anything from GitHub. There are the actual from Meta AI GitHub page, and also we have a fork distribution which was tested. So I'm not sure what kind of changes they may introduce. There may be some conflict. We can take it from here. I open this location, so that's what we don't need. From here I can go to code, download zip, and okay, just unzip it somewhere where I know, and then I would unzip this into, well, for example, I usually put here in my Python folder examples, and I can copy the segment anything main like this. Alright, so this was the second step. And then the kind of the most tricky part is actually that we need to install the all requirements. What we do first, we start this Anaconda prompt. So I go to the start, Anaconda prompt. What I need to do just basically follow all these steps that I have here written. We're opening the prompt, then we create a new environment, which is basically means that we need to put this command. Here it's important that you put the correct location where you installed Miniconda. So because I put here d Python Miniconda 3.9 environments, so that's my location. And after that we make a new environment, which in this case I called segment anything model for MIP, and there's a version of Python. We're creating this environment first, then proceed, yes. May take a while. Then when it's finished, okay, what we actually see here, if we go to this Miniconda 3.9 environment, so we can see that the segment anything for MIB directory appeared, and that's the directory where we have a kind of a copy of a Python with the all required libraries. Now we need to activate it, so it's the next command here, which we type activate SAM for MIB, and you can see here that the base was changed to this new environment that we've created. The next, we need to go to this PyTorch, and there we need to kind of generate the command that we need to run in order to install PyTorch, which is suitable for our system. So we'll just click here. Yeah, basically what we need to do, we need to specify the settings. Again, I put here, there is this configuration that I was using. I guess from the important parts it was that you would like to install it from pip, not from conda, because as far as I tried, there was some kind of certain compatibility issues, and depending what kind of CUDA compatible driver you have, you can use this or the other. Actually, I probably mine should be compatible with this, so I actually will try this one now. I haven't tried it before. Let's see. And then what I do, I'll just select this line from here, Ctrl-C, and then I put this command into this line and hit enter. So what it will do, it will install all this PyTorch libraries that are required to run this this model. Let's wait a bit until it's installed. So now it's installed, Okay, this is actually, I haven't closed this Miniconda setup. It's installed. There is some kind of error with the version of pip. We probably shouldn't care that much about that. So the next step would be just to get this OpenCV. So these guys here, I just select them, Control C, put here, enter. In some of these installations, there could be some issues. For example, in the following step that we need to install these Pico core tools, I had few problems, and then to address this, you can actually see what's the kind of have the additional description how it could be troubleshooted. I had this one, and then let's see how this will go. Okay, it's sort of done, and then finally we need to get this on an X time GPU. It's installed, and then, well, there's optional you can install the Jupyter Notebook. Well, let's just put it, but it's not really needed. Now everything has been installed, and now we don't need this Anaconda prompt anymore. So now we go to MATLAB and let's start MIB. The first step that we need to do is we need to define the path where we have this Python exe. But the Python, there are different Python exe. So there is the Python exe in the main Miniconda installation. Let's just make it a little bit bigger. There is the main one from the base environment, but actually what we need to do, we need to put the one which is from the segment anything. How we do it? Let's actually make it a little bit like that we see both. Okay, we go here, we go to the file, preferences, and in the preferences there are external directories here. And then in external directories we need to specify the path, Python installation path. So I click on the three dots, and then I just go to my Python Miniconda 3.9 environments, SAM for MIB, and select Python and open. So we have it there. You can see these different examples where it potentially can be. Then we need to define the location of directories where we can store this, the actual networks, train networks that we'll be using. Typically, I just put it here on my ctemp drive, but it's nice to also to specify this location. Otherwise, it will end up in somewhere in your user temporary folder. This is fine with this part. The next step, we can go to the tools, segmentation panel in the tools, and there's segment anything module here. And then there is this cogwheel button. So if you press on this, what you need to do, you need to specify a few important things. The first of them, you can pick up which of this network kind of backbone you would like to use. This 0.4, it's the lightest one. It could be used with the GPUs with quite limited amount of memory. And it's while the largest one is actually would probably require maybe 10 gigabyte or something like this GPU memory. Let's pick this one because I can to do it on my workstation. Then there are different parameters, you can play around with those, but defaults ones work pretty well. Then there's the execution environment. If you have a GPU, so you pick up CUDA definitely. If you want to test it, then you can keep it on the CPU. And then now we need to put the path where we put our segment anything. So I can either copy paste the path, and remember it was in the examples segment anything main. It's this path. I can basically just copy it and put it here, or I can actually click this checkbox, and what it will do, it will start this file selection protocol as soon as I click OK. So I press OK, and then now I'll just need to go to my D Python examples, segment anything main, select folder. What it says that now that it actually needs to download this kind of backbone checkpoint. So what we do, press the continue, and then depending on which of these checkpoints you selected, 0.4 gigabyte or this 2.5 gigabytes, the corresponding file will be loaded. Okay, let's just wait for that. Okay, so it's now all downloaded. Well, let's see what I actually have in description. So the following steps here. So we go to the settings, we specify these three main parts, and yeah, and that's basically ready. Now what we can start testing this. So for example, let's see, I select here segment anything as the tool, and we have these three different options that I can talk a little bit later. And then I just do a left click. When you do it for the first time, it actually MATLAB initializes Python environment. This is kind of takes a while, but then as far as it's initiated, then after that the segmentation is quite quick. We can actually now compare these two different approaches with this 2.5 gigabyte and then 0.4 gigabyte. Okay, so it's almost finished, and there's an error. Perfect. I have an error because apparently my NVIDIA driver is too old. Let me just update it. Alright, I'm back. Indeed, the driver was a bit too old. I used this GeForce Experience to update the driver. So now it's updated. And now what I can do, I can again make sure that I updated the drivers and I restarted MATLAB and Microscopy Image Browser. And then actually I had to do it again and do this, the preferences to specify the path directories, because I wasn't able to close the Microscopy Image Browser before the installation. So if you go to that step, so close MATLAB first. Okay, and now in this interactive mode, what I can do, I just use the left click and then shift click, and then I can basically tweak a little bit the things what is getting segmented using the control clicks. So let's see, for example, here on M, on I, see here center problem, but I use the control click to take it away, and then R. Oh, okay, let's take the central part away. In general, this segment anything, even though it's been trained on these normal standard images of dogs, cats, and so on, it still works in microscopy images because, again, the shapes in microscopy images still resembles the standard shapes that we see in normal life as this kind of blobs, different kinds of lines and other objects. So that's why it still will work for the electron microscopy or light microscopy. Now we'll continue and let's take a look on the examples how we can actually use it for segmentation. Let's take this focused ion beam dataset, and in this dataset I was using segment anything to detect mitochondria. You can go to this. First, the main method is interactive. It means that it's just the segmentation done by basically clicking with the mouse. And first we decide what would be the destination. So default option is the selection and replace. So what it means that if you click, it segments something and then it's painted in the green, which means it went to the selection layer, and you can press C to remove that selection. With the left click I segment something, then I use hold the control key and then left click in order to remove area that I don't want to be included. If I want to add something, I hold the shift and click somewhere else, and then the second object will be added. But again, if you segment individual parts, it's easy. Like you see, that it probably won't be that noise, but let's use the control click. Well, it managed, but to me it looks like it's better to work with the objects one by one. That was the replacement mode, which means that if I click again here, that all previous objects will be removed. And the way segmentation works, it only works on the part of the data which you see on the screen. So you see, if I move my window down, you see that the part that was out of the screen, it was not really, updated. Okay, the next mode is called add. When I click and then I click, it will actually add up the things. So let's see with the control, then let's go, like for example this one, let's make control click here, let's get this guy, control click here, let's take this mitochondria. Well, I'm not sure how was it good? Like maybe here, then this one. So you can see it's actually very easy. You can just shift click to here, control click to here, next one and next one without the ER profile. Yeah, you see it's very quickly, and then you can quite easily get segmentation of this kind of especially blobby objects. Things like ER a bit more tricky. I won't talk about this now. Then the other mode is called subtraction. It means that when you click, that part will be subtracted, but okay, it's not really that much useful. It's either add or replace, or add plus next material. Well, what is actually this one is that we can use our destination as the modal, and then let's say if we in the standard mode, which is called add or maybe replace. Okay, add is fine. So let's remove this and make a new material, which I called Mita. Oops. And then when I click here, it adds directly to this material. Let's say I click here. You see, it added it with the problem, but while I'm still haven't pressed the left mouse key, I'm working on this object. I can hold Control key and click, and then it gets removed. If it gets really messy, and then for example I clicked Shift to get the other one, and I don't like this, I can press Ctrl Z, and it will undo the last object. So it will undo the operation which happened after the left mouse click. So let's go on this one, hold Ctrl here, and then it's done. Again, left click, Control click, done, left click, and so on. So this is like one of the options. Another interesting option is called here add plus next material. So this is super cool if you're interested to get generate a training set for instance segmentation. What happens there? Let's make a new model. Make it like 65,000 materials. Now when I click here, it goes to this material number 2 and opens up material number 3. So I click on that. So this is gonna be a Control click. Number 3. So now left click, this will be number 4, Control click here. Then let's go here, 5, 6, 7, 8, and so on. So basically you can quite easily and quite quickly generate this training set if you really need to have like an instant segmentation. Right, what are the two other modes? Like one of the other modes called landmarks. In the landmark modes, if you don't remember how it works, then we can press on this help, and in the help we go segmentation tools, and there's segment anything modal. Well, scroll doesn't work here. Yes, so and there is how to use, and there is this landmark mode that describes this. We can use this landmark mode, for example, to segment objects that go through the volume. For example, we can do for segmentation of this nuclear envelope on this. Okay, well, this is like a small data set. You can do it like in the interactive mode, but assuming this is something bigger, we need to provide this annotations landmark. So what I do, I click on this here, or you can go to the annotation tool and open this annotation list. Let's go back here, and then I click on the first slice, and then it's important that because I'm interested to segment nucleus, I put index 1 here, so that's going to be my object. Then I go to the last slice, click here, put 1, that would be my other object. Then in this annotation list, I can select these two guys, right click, and then I can choose interpolate between selected annotations. It will actually put this, this label on each of the slices. Then I need to do the same for the background. So if I click here outside the nuclear envelope, put 0, index 0, and then do the same for the last slice, 0. And then here I just again select these two annotations, right click and interpolate. So now I have the list of these two kind of labels that go through the whole data set. Now I can select 3D stack, landmarks mode, selection, replace, and press segment. So what it goes through all of the images that I have, and yeah, basically segments the nuclear envelope there. There is one more option which is called segment anything. That's how originally the tool was envisioned to be used. So basically you just press one single button and then it splits all things which you have in your image into different classes. In my experience, it sort of works a little bit slow. Again, maybe I need to tweak a little bit these parameters that we have in the settings. But on the other hand, it also doesn't really produce that great results, just because, again, the network was trained on the images for normal, like normal structures. Well, here it's kind of mixed stuff. So you can see the mitochondria got segmented, and Golgi was segmented, nuclear envelope was segmented. But again, I'm not quite sure whether I would really like to use this. But of course, you can, for example, select the 3D stack, press the segment, and then it will just process the whole stack. And then after that, you can try to remove this big, for example, objects, and try to, continue from that. So that was the application of segment anything. I hope it was useful and it's a bit more clear how you can actually use it for your segmentation tasks. Thank you so much.